Pascal, lovely to talk to you as ever. Welcome to the Athlete Climate Academy.
Hi, thank you.
We got into it quite hard then on, we spoke about everything from glaciers worldwide to the state of glaciers in the Alps. You're out in Switzerland at the moment. And we talked about we go right into like what it actually is a glacier. So I think for this conversation, should we start off about what is your definition of a glacier? See if it differs to mine.
Yes, let's start with that. So, okay, glacier starts because at a certain altitude, above sea level, usually above 3,000 meters in the Alps, it snows so much that, well, the snow stays for longer than 1 year or even 2 years. And so it becomes a firn, it becomes eternal snow, and that snow compacts and it becomes ice. So, well, a glacier is a glacier as soon as you have like perennial ice that stays for several years. And well, how a glacier works is basically you have this snow accumulating at a certain altitude because it snows every winter and even in summer, and it compacts, and this dense snow becomes ice, and the ice flows downhill because the mass accumulates, and ice is actually like a viscous fluid. It behaves. It flows downhill and lower down. At some point, it reaches an altitude where it's warmer and it melts. So basically, yeah, it's ice volume that stays for longer than a year, I would say, and it has to have a certain size. But I think that depends who defines it. Yeah.
Yeah, there's definitely some like really tiny. I think I remember seeing the smallest glacier in the world. Was that out in? I think that was out in the States, but it was a very tiny thing that stayed there for a while. That they said was the smallest glacier ever. But I suppose that also differs to an ice cap, which is one that doesn't move under its own steam.
Yeah, actually, an ice cap can also move. Well, an
Oh,
ice cap is maybe special because it's not defined by the altitude, but it's defined by the latitude much more. It's
right.
cold enough because of the latitude, because of the high latitude. But also, what is very special about ice shelf or so is that it maintains itself. Basically, it reaches a high enough altitude. It maintains itself in equilibrium because it's thick enough. So, for example, Greenland, I mean, it's let's say up to 3 kilometers thick. It reaches 3,000 meters above sea level. The base is at sea level, or even below in some places. And it's only cold enough up there because of its own thickness. So basically, it creates its own equilibrium.
Which is then different again to things like Arctic sea ice, which is stuff that
Yes.
sits in the water, which is will change year in, year out. So what we're saying is there's lots of different types of ice depending on where it's sat. Maybe it's sat on a continent, like in the Alps. Maybe it's sat on a pole, like Antarctica, or up in, which is on land. But then in the Arctic, it's in the sea. So there's lots of different types. But I mean, the one thing that's definitely tying all these together at the moment is the threat of global warming and climate change. I mean, that's the thing that, I mean, ice needs to be cold
Exactly.
for it to survive. So what is the current state of, you're out in the Alps, you're an environmental engineer, you're studying out in Switzerland. Switzerland has, I think, more glaciers than any other country in the Alps. I think I'm right in saying.
I
Is that
think
true?
it does. It has like a
I think so.
1,400 glaciers.
Oh my gosh. So what is the
Right.
current state of the glaciers out there at the moment?
So, well, yeah, right now in Switzerland, all of the glaciers are receding and pretty quick, like only since the year 2010, I think they have been losing like 17% of their volume, which is enormous. I mean, just over 10 years. And yeah, the projections are also not very good. Of course, there's some that are bigger, like Aletsch Glacier, which is currently still about more than 20 kilometers long, and that can persist until the end of the century under, let's say, a relatively good climate scenario. But they're all retreating pretty quick. Mhm.
And that goes across the entirety of the Alps. There's going to be, like, around the world, the way that the global warming's working, the way climate change is working, it doesn't necessarily mean that we're going to get less rainfall, less snowfall everywhere. It's going to be a little bit different here and there. And we'll get on to kind of worldwide view of those glaciers.
Mhm.
But especially in the Alps, I'm seeing it when I'm out. I suppose all our viewers will be coming out to the Alps at some point for running or climbing or something. Anecdotally, I know that you study this kind of thing, but anecdotally, do you see it over time,
Oh
like
yes,
just
I
by
mean,
looking?
yeah, that's very important. Both, let's say, both as a runner and a mountaineer, and as a glaciologist, because okay, we have been working for like 3 summers now on the same glacier, and its glacier tongue is reaching down to like 2,500 meters, and like you can visually see it receding. And actually, what is impressive, we surveyed it with a ground penetrating radar. It's like a radar antenna where you can see through the ice to the bottom of the glacier. And like where we surveyed in 2017, now there's just rock and a big channel collapsed. Like there was a big subglacial channel where the water flows under the ice, and it was melting out so quick from the inside. There was like a hollow that is like 5 meters high where the water was flowing. It all collapsed within 1 month. So yeah, you can see it, and
Mm.
also people who go frequently to the mountain, you can say that you can tell that if you go onto, for example, the Haute Route in some summers, usually in the upper parts you always have snow on the glacier, and the crevices are well covered, so you can easily walk over them without major hazard. And now often they are also bare ice, or the snow bridges are very small, so you can notice that very easily.
Wow. Yeah, I mean, I live in Wales, in the UK. We haven't had glaciers here for a long time. But and I visit the Alps as frequently as I possibly can. But when I come back, kind of like annually, for example, I suppose it's like being with someone or knowing a friend, and they change over time. You don't necessarily notice because you're with them all the time, but when you see them once every kind of few years, you go, "Wow, that's a massive difference." So I definitely see it. But the one thing that I've been fascinated by for the past few years is the fact that, in the UK and especially in Wales, we don't see glaciers all the time. So
Mhm.
we often we often see them on TV, on a documentary, but we perhaps don't go to them. So we might not think they do anything. But I've been
Exactly.
fascinated by the fact that so many people rely on them for water, electricity, agriculture, like all these things
Exactly.
matter, right? Especially in the Alps.
I mean, even us in the Alps, I think we're underestimating how many people are relying on it. I mean, we're just thinking about, oh, well, the people in the Alps, they rely on the glaciers, like for tourism, for water, and so on. But we don't realize, I mean, they feed the major rivers that flow into the European countries, right? They flow,
Yeah.
I mean, the Rhine River, the R flows into the Rhine. Then we have, the Inn that flows towards Austria. We have all the major rivers, the Po in Italy, and so on. They all they are all fed from the Alps, and the same is true for other big mountain chains, right? The Himalayas, where from starting from the Himalaya, there's these major rivers like Hindus and Ganges and the Yangtze and so on. They are all fed from the Himalayas, and they feed overall. Well, we've talked about this before, like 1 billion people with water,
Mm.
and also hydropower, some of them. And the same is true for other parts of the world, like the Andes and so on. So yeah, I think many people in the Alps are not even aware of this. They just think, oh yeah, we have our hydropower and or maybe some agriculture and local drinking water from that, but they don't realize that it's all downstream as well. Yeah.
That downstream is the perfect term for it, because it's something in the region of 90% of lowland Europe gets their water in some kind of way through meltwater from the Alps. And like I say, the Andes will be there, the Himalaya. There's a bunch of different places that have these water towers that sit up high and are basically kind of storage facilities for, depending on how you want to use it, the water itself or the energy that you can get that's fed. The water comes off, rolls downhill from gravity. You can use that in some way to drive a turbine and get hydroelectric power. I know Switzerland does that
Yeah.
quite a lot. You
Yeah.
guys get a lot of hydroelectric power, right?
Yeah, I mean, must say Switzerland has exploited since we started, like in the 50s, almost all of the hydropower potential that is possible to exploit. Let's say technically, but also in terms of like respecting some minimum environmental standards. So 56% of our electricity is hydropower in Switzerland.
Wow, I didn't
And
know that.
yeah, so and what is crazy is like there's big dams, but also what people don't know, there's many water intakes that come from small valleys. So basically, there's maybe no dam in that valley, but they take the water from a small stream and they divert it to a big dam. So many small streams are also diverted to these big dams, and some galleries they can be up to like 24 kilometers long, all through the mountains. It's insane, like, and so yeah, it's really really fascinating. But also, I think nowadays maybe I'm not sure this would be built again because you realize it's also a certain impact on ecology. But I think now we also have technologies to, for example, fish ladders and so on to circumvent some ecological problems to make fish pass or yeah. Um, and then yeah, as you mentioned, it's very important to mention it's like storage power towers, like the glaciers. So maybe if there's no more glaciers, we would still have. I mean, we have a lot of precipitation in winter, then we have snow melt, and we have some rain in summer, but the seasonality strongly changes, and basically what we don't have anymore is this huge storage of ice and basically then water that the glacier brings us. Yeah.
And I suppose it's important to say that like between the last ice age and now, we've already lost like what was last ice age coverage, about 32% of the land was under some sort of ice, and then now we're down to about 10%. So we've lost a lot. We weren't supposed to be losing the. I think the big thing is we were going to continue to lose it in some sort of way, but the pace at which now we're losing it has gone up massively. I think I saw a figure that was like 2/3 of especially the Alps by the end of the century. Of the glaciers in the Alps would disappear.
Exactly.
So, but it has practical ramifications, right? Like that's the thing I keep coming back to, is that agriculture is already kind of suffering on
You
the
can
in the
already
high
see it.
parts of the Alps.
Yeah, and also
Yeah.
in the flatlands. I mean, we have had several summers since, for example, the summer of 2003. It's very famous for being very hot and dry, where we had big droughts for agriculture too. Then again, several summers like 2015 and also a bit in 18, where just yeah, there was not enough water already. Um, but what you yeah, maybe it's important what you mentioned before about the ice age. It's important to mention. I mean, of course, there was a natural cycle, and you have glaciers advancing, retreating, and so on. But we exiting the natural cycle basically by humans putting in way more CO2 into the atmosphere. Well, you've probably talked about that before, but
We covered this.
like more than in the past 800,000 years, and so we're out of this cycle, and now we're entering kind of uncharted territory soon, I would say. And yeah, I mean, maybe you have seen this. There's nice papers about, for example, how the glaciers retreat up to the year 2100, like that. For example, Aletsch Glacier, if we follow the RPC 8.5 scenario, it retreats like all the way, like there's nothing left of any glacier in the Alps, to be honest. But then if we make a major effort for climate protection and for reducing our emissions, we can save part of this glacier, at least a third of what's left
Yeah,
now.
and I think that's important. I think that there are some positive outlooks on this kind of stuff, but also, like you say, the hydroelectric stations could stay there because of seasonal snow and rainfall.
Yes.
We might still get those. There's still going to be agriculture that can work in the lowlands because of that as
Yeah.
well.
Yeah, it's
It's
important to
not
say that.
necessarily all doom and gloom.
Yeah, it's important to say that we can adapt to it, and we can. Yeah, it's of course it's hard because we have to adapt in a short time, and as I yeah, what is also there was a recent study by some Swiss researchers is that if the glaciers retreat quick, we know that underneath the glaciers from radar soundings, there's some over deepenings where the glacier like eroded the rock, and there's basically a potential lake underneath the glacier. When the glacier is gone, you could use some more surface for hydropower again. You could create smaller dams higher up. Of course, it requires a lot of effort and all. And of course, this would never replace the whole volume of storage that the glacier occupied, but you could use that. And of course, hydropower is not over, but then we have to use it in a different way because, as you mentioned, like for example, for the month of August, the prediction is like by the end of the century we would have 60% less water than we had like between the 80s and the year 2000. Yeah.
Yeah. Well, I suppose at the moment with the glacier where it is, you take any glacier, that August might be the prime kind of like peak output because of the melt that's going on.
Yeah, peak is the key word. Like right now, we're actually already past peak water for most Swiss glaciers. So peak water is a term for when it's getting warm enough that glaciers melt extremely strongly. We measure that on our glacier. They melt up to like 10 centimeters a day in thickness of ice. And if there's still enough ice left and it's very hot, of course there's the most water flow coming from melt. We call this ablation as well. So from ice melt. And then because the volume of the ice is reduced steadily, there's less and less water coming at some point, and the peak water is over. And we are already entering the phase where at some point less and less water is coming because the melt is stronger and stronger, but there's not so much ice to melt left. So yeah, we are entering already the phase after peak water, yeah.
We started this before we started talking. I did say, well, let's try not to have it all kind of doom and gloom. It's difficult, isn't it, not to have that eco-anxiety and say, it is all going wrong.
Yeah, it's true. Yeah, I mean, you can also, that's why I try also to be optimist and say, okay, we can do something about slowing down climate change, and also to what's left. I mean, there will be warming anyway, even if we do big efforts. We can adapt, right? I mean,
and I think there'll be cooling in the future as well. Like it's one thing I really want to write a talk called "Why I Don't Care About Climate Change," and it's all kind of based on an astronomical projection of the Earth, and it's like the Earth doesn't matter too much. I think we'll hit a point, as there has been in the past, where we get to maybe close to 0% ice on the Earth's surface, and then something will happen. We'll go back to a different cycle and it'll start to come back. But it's the major impacts of all of this, including the glaciers, is how we deal with it, right? Like that's the big thing.
Yeah, I mean, the question is how can we live well still in this environment that's changing very quickly, and what we didn't talk about so far is, I mean, the natural hazards, right? Some may decrease, but many may increase because we have as we saw, like on the south side of Mont Blanc, Courmayeur, there's a hanging glacier where they had to close part of the village down because it started sliding very quick. Like there's a lot of melt water at the base of the glacier, and it lubricates the base and it makes it slide more quickly, and it could break off. So there's such hazards, but also glacial lake outburst floods. There was recently one, I think this spring was that in Himalayas. In India, where there was a big, there was not a glacial lake outburst, but there was like more kind of permafrost-related ice and rock avalanche that triggered then a big flood in a major river, and that killed many people. And such hazards, especially in the Himalayas, where there's less, I mean, it's so vast there, and there's less infrastructure, people are less protected against such dangers. There may be huge impacts. Also because it's bigger, right? The terrain is bigger, and there's still much more ice left, and will be also. So such hazards is one challenge, I think.
But like we keep saying with these kind of things, that I was just on a different call and saying the mitigation is the thing. Like we can't really change projections for the we're going to lose in the Alps maybe 2/3 of the glacier by 2100. However,
optimistic.
it's the mitigation part, right? Like, let's try our best. It doesn't mean we shouldn't try better to reduce carbon emissions to make sure that the mitigation is
Yeah, like in terms
accepted.
of, you mean like let's try our best not to lose too much.
Yeah,
Yes, and even even 2/3 is probably optimistic, but yeah, I mean because the Alps, I mean they are not that high, and there's not so many long glaciers left compared to the Himalayas or so. Yeah, and then there's but you're right. I think we should try our best, and because also to reduce the cost, I think what we saw also from the recent floods in Germany and so on, the costs may be so high, like way higher
yeah.
than the measures we take against the warming. Yeah, if we don't take them like fiercely enough and early enough. Yeah.
Yes. So what we're saying is there'll be less water, less electricity, less agriculture, more natural hazards,
Yeah.
higher coastline. We've got our work cut out for us.
Yeah, now we didn't even talk much about sea level rise, but that's a huge thing too, right? I mean, that's more
Yeah.
related especially to the ice sheet. Also, the alpine glaciers contribute, but yeah, so that's
Yeah,
the main
there's
point.
lots to take on board, Pascal, which means we'll definitely have you back for more
Yeah,
conversations in the Arctic Climate Academy. For sure. We got lots and lots to do. But for now, Pascal,
sure.
thank you so much for joining us. I really appreciate it.
You're welcome. Thank you for the chat.
Thank you, man.